Today's video is going to be on Chapter 2.4, solving equations with the variable on each side. So today what we're going to focus on is what happens when you have not only two variables, but one on each side of the equal sign. Keep in mind that variables or letters serve as numbers, so whatever you do to one side, you would need to do to the other. And there are a bunch of ways that we could start this problem. What I'm going to try to do, and remember the goal is to isolate the k, so you want to get the k by itself on one side of the equal sign. It doesn't matter if it's on the left or on the right. I'm going to try to keep the k onto the left side so it'll stay positive. So the first thing I'm going to do is get rid of this 2, or move this 2, which means to eliminate that, 2 minus 2 is 0, which means I need to subtract 2 from that side, and I'm left with 5k equals 3k. Negative 6 minus 2 is not negative 4. This should be negative 8. All right, then my next step is going to be to get the k by itself on the left side, which means I'm going to have to subtract the 3k. This will go away. 3k minus 3k is 0. All right, additive inverse property. 5k minus 3k, this is 2k. 0 minus 8 is negative 8. So remember, this negative needs to come down. And then finally, I need to get rid of the 2 that's in front of the k, so I'm going to divide both sides by 2, and I should be left with k equals negative 4. I'm going to have you practice this. 3w plus 2 equals 7w. Please pause the video at this time to practice this problem. Now in this particular problem, it may be easier for me to move the 3w over to the right side, meaning that the w will end up on the right, and that won't matter. So I'm going to subtract 3w. 3w minus 3w is 0. This leaves me with 2 equals 4w. Now, this is where people sometimes make a mistake. I need to divide by the number that's in front of the w, which means I'm dividing both sides by 4. Okay? This becomes w. Now, a lot of people are going to reach for the calculator, but 2/4 is not something you need your calculator for. Okay? If you get 0.5, it's because you're typing into the calculator. I want you to think of this as a fraction. I want you to reduce that fraction, and you should get 1/2. W equals 1/2. All right, now let's put a couple of things together. We're going to end up using the distributive property to solve this. So remember, I'm going to take this 6, I'm going to multiply it here, and then there, and then this 1/3 here, and then there. And once I get rid of the parentheses, I can start to simplify things. So this becomes 30m minus 18 equals 1/3 times 24 is 8m plus 1/3 times 12, which is 4. Now I'm going to keep the m on the left side, so I'm going to end up moving this 8m over. You could subtract 8m now if you want, or what you could do, I'm going to add the 18 first. The opposite of negative 18 is positive 18. This becomes a 0, and I have 30m equals 8m plus 22. Now going to subtract 8m from both sides. I'm going to have to start to get a bigger board. Cancels out, and I have 22m on this side, and then positive 22 on this side. And then the last thing that I need to do, I'm going to raise this up so you can see this. I'm going to divide by the number in front of the m, which is 22. This becomes m equals 1. Sorry, I'm a little jumbled. I'm going to have you practice this. 8p minus 10 equals 3 times the quantity of 6 minus 2p. Please pause the video at this time to practice this problem. So first thing I want to do is distribute. 8p minus 10 equals 18 minus 6p. I would tell you I'm going to put the p on the left side, but again, you wouldn't necessarily have to, and you should come up with the same answer. So I'm going to add 10 to both sides. Goes away. I've got 8p equals 18 minus 6p. Sorry, not 18. 28. Then I'm going to add 6p to both sides. And I'm left with 14p equals 28. And when I divide both sides by 14, you should get p equals 2. Now, like we talked about before, you could put a 2 in here and a 2 in here and check your answer. Make sure that it works. I want to show you two special cases, two odd things that might happen. You may start to see the problem. So I'm going to work through the beginning of it relatively quickly, if you're okay with that. I'm going to distribute there. So I got 5x plus 5 equals 15x minus 4 minus 10x. Now what I'm going to do is simplify on the right-hand side, since I have like terms. These two are like. Okay, so I can put them together. So this becomes 5x plus 5 equals, sorry, that should be a 5. 5x, right? 15 minus 10. 5x minus 4. Now here's where some of you can see the problem. One thing I could do, let's say, is subtract 5 from both sides. So I subtract 5, and I'm left with 5x equals 5x minus 9. Remember, negative 4 minus 5 is negative 9. And then what I would do is I would subtract 5x from both sides. And I'm left with 0 equals negative 9. Now my problem is, well, I got two problems. One, the x is gone. And two, 0 does not equal negative 9. So for this particular problem, my answer would be, if you remember the empty set, and the empty set means there is no value for x that I can substitute in to the original equation to make this statement true. All right, I have one last example for you. That looks like this. You can work ahead of me if you feel comfortable, and then kind of pause it or slow down when you get to a place where you feel stuck. 6x minus 3 minus 7 equals, sorry, this should be an x, not a b. Equals 6x minus 10. Now when I combine these like terms, what happens is I have 6x minus 10 equals 6x minus 10. And what you'll notice at this point is the left side equals the right side. So I could add 10 to both sides, subtract 6 from both sides. So let's say that I were to add 10, and I would end up with 6x equals 6x. And then if you divide by 6, you end up with x equals x. So, and if you started up here and subtracted 6x, you would have ended up with negative 10 equals negative 10. No matter what happens at the end of this, you're going to have a statement that's true, right? A statement that will always be true. And so this is when we write all real numbers, and it's because it doesn't matter what number you choose for x. That number could be positive or negative. That number could be a decimal or a fraction. As long as it is a real number and you substitute in for x, this statement will always be true. All right, thank you very much for watching this video, and I will see you in class.